So in this notebook, I'm going to demonstrate how we can make interactive slideshows with the notebook. So in its normal manner, this is what a notebook looks like. You see over here, I've turned on this drop-down menu, which allows me to specify whether I want this cell to be a slide in a slideshow, a sub-slide, a fragment, skip, or just notes that I can see. The way that I turn those on and off is if I come over here to View and come over here to Cell Toolbar and I specify I don't want to view anything, or I want to view the metadata, view the options for a slideshow. With this as a slideshow, then I come over here and click on this slideshow button, enter exit live reveal show, and now my cells, as I've specified them, are rendered as slides on the screen. And I have go down my sub-slides and go back and forth on that. Or I can go to the next slide. Now what I'm doing here is we have an example of teaching the use of try except, exception handling. And we took as our example the definition, defining a sinc function. Now mathematically, a sinc function is defined as the sine of pi of x divided by pi of x. And an obvious question is, what happens when x equals 0? As we all should know, division by 0 is undefined. And that's because if we allow division by 0, we introduce contradictions into our mathematical systems. But what about the case of 0 divided by 0? That seems to be, perhaps in a different area than 7 divided by 0. And so here I've got a link to Peter Alfeld, who's a math professor here at the University of Utah, his webpage about why division by 0 is undefined. And here's his discussion of how to think about the indeterminate case of 0 divided by 0. And basically what he's describing here is a limit process of looking at what's going on in the denominator as we get closer and closer to 0, and looking at what happens to the numerator as we get closer and closer to 0. And what he's describing is actually simply L'Hopital's rule, which I have a link to here in Wikipedia. So if we use L'Hopital's rule, which tells us to take the derivative of the numerator and take the derivative of the denominator and look at the limit as x approaches 0, and I got to resize things here to get it on the screen, we see that the limit of this function is actually not going to be undefined or infinite, but it's actually the value 1. So with that knowledge in hand, let's try to use some of our newly learned programming skills to define the sinc function. And we could either use a try except, or we could use an if-else block to define this. And so what I'm asking the students to do is write a Python function that implements this mathematical function sinc of x. So here in our slideshow we have an actual running cell. And it's what I need them to do is we're gonna edit the cell. So I could just to convince you that this is actually live. That as I change this function, my slideshow is functioning. So I'm going to do a try. So I'm going to try to return math.sine of math.pi times x divided by math.pi times x. If I get an exception like I remember right, 0 division error, then I'm going to return the value 1. Let's see if this works. So now I've got a function that's working properly. I could try to rewrite this in a way that I could, like if x equal to 0, then return 1. Well, let me do it this other way. If x is not equal to 0, then I'll return that. Else, I'll return 1, and I'm able to get the same behavior. So we can take that and we can plot this, and I could change the range of my function. And let me change this here to get a different behavior. So this is a slideshow where I actually have a live interactive Python environment that I can modify, edit, run code, and get output.